So let's find the second derivative of y with respect to x, that's a y, if xy equals x. Now remember, with implicit differentiation, this is something where we don't have y isolated. We could actually isolate y pretty easily with this, but we're not going to for purposes of demonstration. And what we're going to do is we're going to take the derivative of each side, but when we take the derivative of y, this is an equation with respect to x, and so we have to use the chain rule on it. Anytime we're taking the derivative of this y, we're going to have dy dx as the little piece that goes for the inside function of the chain rule. So we notice that these two are multiplied together, so we're going to start off by using the product rule over on this side. So the derivative of x times y plus x times the derivative of y. Then we're going to take the derivative of this side. The derivative of x is just 1, and there we go. So the derivative of x, like we just said, is just 1, so we have 1y plus x, and then the derivative of y with respect to x is what we're looking for, so it's just dy dx equals 1. Let's subtract y from both sides now, so we've got x times dy dx equals 1 minus y, right there, and then we divide both sides by x. We've got dy dx equals 1 minus y all over x. So far so good, except we do need to find that second derivative, so let's keep going. So far so good, except we do need to find that second derivative, so let's keep going. I've gotten a little far over on the right here, so I'm going to start over here. So the second derivative, I see that I've got division here, so I'm going to have to use my quotient rule. F prime g minus fg prime over g squared. So let's do the derivative of 1 minus y, and that's going to be multiplied times x minus 1 minus y times the derivative of x all over x squared. The derivative of 1 is just 0. The derivative of negative y is going to be negative dy dx. We've got that x along for the ride. We're going to subtract 1 minus y, and then the derivative of x with respect to x is just 1. It's all over x squared. So d2y dx squared. We've got negative dy dx times x, and then distribute this 1, distribute this negative, minus 1 plus y all over x squared. Now this is all well and good, except that we really want to end with only x's and y's. We'd like to get rid of this dy dx if we can. And it turns out that right up here we know exactly what dy dx equals. It equals 1 minus y over x. So we can just substitute this right back in there. Second derivative of y with respect to x both times. Got negative 1 minus y over x minus 1 plus y all over x squared. Oops, forgot my x. Should be another x right there. Because these x's are about to cancel out, then when we distribute this negative, we've got negative 1 plus y minus 1 plus y over x squared, and the second derivative of y with respect to x both times, and we combine like terms, we have 2y minus 2 over x squared. A lot of work, but there we go, we have our second derivative. We're going to do a very similar thing on one final problem, and then we'll be done with these notes. So let's find the second derivative of y if xy equals y squared. You can go ahead and try this one on your own if you want. It's a little bit tricky, so if you want to walk through with me, that's entirely fine as well. So just like we saw with the first one that we were doing like this, this is going to require the product rule. So we're going to have the derivative of x times y plus x times the derivative of y. And then here, this isn't the same as the variable down here, so we're going to have to use a chain rule. We've got 2y, and then times the derivative of y with respect to x. Derivative of x is just 1, so we have y plus x. Derivative of y with respect to x is what we're solving for, so it just gets its own little variable, so to speak. And same thing over here, derivative of y with respect to x, just like that. Now we want to get all our dy dx's on one side, so I'm going to subtract 2y times dy dx. And I want all my non-dy dx's over on this side, so I'm going to subtract y from both sides. Now I can factor out this dy dx. So I only have one of them. And then divide both sides by x minus 2y. So that I have dy dx by itself. At this point, this would be great if I was trying to find the first derivative. I'm trying to find the second, so let's go at it again. The second derivative I'm going to start off with this. I see that I've got division, so I've got the quotient rule, f prime g minus fg prime over g squared. So we've got the derivative of negative y times x minus 2y minus negative y times the derivative of x minus 2y all over x minus 2y squared. So second derivative of y with respect to x. This would be negative 1. Bring down the exponents, subtract 1 from the exponent. This is y to the 0, but because this is a y and it doesn't match, we have to do the chain rule. So there's a dy dx multiplied by that negative 1. X minus 2y is along for the ride, minus negative y. The derivative of x is 1. The derivative of negative 2y is negative 2, but this y doesn't match the x, so we've got to do chain rule, dy dx. All over x minus 2y squared. Very often when we're doing these, something nice will sort of simplify out of here, so let's see what we can get if we simplify. So I'm just going to go ahead and distribute right here. So we've got negative dy dx times x. Negative times negative is a positive, 2y dy dx. Negative times a negative is a positive, so when that distributes, it's positive y minus 2y dy dx all over x minus 2y squared. Nice thing here, now we see it, these two subtract out to be 0. D squared y dx squared. So we've got negative dy dx times x plus y all over x minus 2y squared. And remember, we can go back and pick up what our dy dx was up here, put that back in down here for this negative dy dx. Second derivative equals negative, see that was negative y over x minus 2y, multiply by x, add y, all over x minus 2y squared. Second derivative. Negative times a negative is a positive, and we've got that x there. So we've got positive xy over x minus 2y. And then to simplify this completely, let's get some common denominators here. Okay, I'm going to have to bring this up because I'm out of room. So our common denominator up in the numerator is x minus 2y. That's all over x minus 2y squared. And I've got xy plus, here's another xy minus 2y squared. This is the same as all of that over 1. So I can add these two xy, so I've got 2xy minus 2y squared up here, all over x minus 2y. And then this is the same as multiplying by the reciprocal. Two xy minus 2y squared all over x minus 2y to the third power. We can factor out a 2y up here if we want. We wouldn't be able to cancel anything out though, so this would leave it pretty much in equivalent form. So let's go ahead and stop there. If you factored it further, it's still correct.